Hi everybody, it's Miss V. Hope you're having a great day and welcome back to another science video. Now, for Tuesday and Wednesday, we learned how to calculate velocity, distance, and time with our three new equations that we know. We also know that it's important to convert our units if some of them don't match up before we put them into our calculation. Now, today I am posting the answer keys to those practice problems, so make sure you take a look at those and make sure that you're on the right track. If not, please contact me so that I can help you. Now, today we're going to be talking about how you graph velocity or speed by using distance-time graphs. Now, I'm sure all of you have some experience with graphing before, and some of you will enjoy it, some of you won't. However, it is a very useful tool. It can be very difficult to make sense of a table full of numbers that show distance and time, right? You might look a little bit like this. However, if you plot these numbers on a graph, you can see all information at once, and it kind of tells a story. It becomes a lot easier to understand, and that's what we're going to do today. So let me explain this a little bit more. Here's an example. Little Red has become a teenager with a license and has traded in her basket for a new convertible and is now driving to Grandma's house for her visit instead of skipping through the dangerous wolf-infested woods. It takes 4 hours to make the 360-kilometer trip. So, using our knowledge from yesterday's class, we can now calculate Red's average speed. Now remember, in order to get full marks when you're doing a calculation problem like this, you always have to show me the copy of the equation. Okay, so we're going to be trying to look for speed, and we know that speed is equal to distance divided by time. I also know that my units match up because it'll be my distance is in kilometers, my time is in hours, so it will end up in kilometers per hour. So now I will plug in my numbers and do my calculation. So I know that Red's average speed is about 90 kilometers per hour. Now this is where the distance time graph comes in. Now the sign over here, if you noticed, says that Red is driving in a 100 kilometer per hour speed zone during the entire trip. Does having this average speed guarantee that Red did not get a ticket for speeding during her trip? I want you to think about that. So our average speed was 90, but does that mean that she was always driving 90 during the entire road trip? If you said no, you're correct. Red could have been speeding for part of the trip and then slowed down considerably for another part of the trip. By having really high speeds and low speeds, we will average those out, and so the average speed is 90 kilometers per hour. However, during that time, if she was speeding and a cop found her, she definitely could have still gotten a speeding ticket. So, knowing the average speed doesn't tell us everything that's going on. So if we need to know more about an object's motion than just average speed, a distance time graph is going to tell us that. It can tell us a lot of things, like where it was at any time, whether the object was speeding up, slowing down, or just moving along at a steady speed, as well as how fast that object was going at any time. A distance time graph of Red's motion would let us figure out if she was speeding at any time during her trip or if she was going very slow any time during her trip. Now, to make this type of graph, we need to measure where an object is many times along its journey. So this means maybe at the 1 hour mark, I would want to know how far away Red was, maybe the 1.5 hour mark, the 2 hour mark. And by doing this, you get a very good picture of how fast she was going at different times. All right, so a velocity graph here is called a distance versus time graph. That is what we're going to be calling it, and you'll see why in a minute. Now, if you're not using distance, you may be using displacement. In that case, you just change out those two words, and instead this is now a displacement versus time graph. Now, when you draw distance versus time graphs, you're going to put your time on the x-axis, or the horizontal axis on the bottom, and you're going to plot distance on the y-axis, which is the vertical axis going up and down. You're also going to make a line of best fit, and this joins the data points and gives information about the velocity. So sometimes you make a line of best fit, sometimes you just connect those dots, and that's going to tell you how fast that object or thing was moving at any given time. So here we go. We have a graph here that I want everyone to look at, and this is a distance time graph for a lawnmower. Now, it's been raining, so hopefully within the next week or so, we're all going to be mowing our grass and having some nice warm weather. And maybe this distance time graph will be you. Now, notice that the title provides two pieces of information. Whenever you're making a graph, you always want to include these two things in order to get full marks. If you look up here, it says distance time graph for a lawnmower. It identifies the object being studied, the lawnmower. It also identifies the variables that are measured for the graph, also known as just what's on the x and y axis. You can simply just do this versus this of A and then put in whatever you're measuring. This gives us a really good idea of what the graph is about, right? If it doesn't have a title and you just hand it to someone else, they don't actually know what that data and that information is being used for or recorded for. So this is why it's really important that you always have a detailed title on each of your graphs, especially in science. All right. You also have these two axes that also have important piece of information. They show the units for each variable, which is very important. So time down here is measured in seconds on the x-axis, and your distance over here is measured in meters on the y-axis. We also need to know the distance and the time units because those are very significant. Seconds are very different from hours, and meters are very different from kilometers. So this gives us a really good idea of how fast that lawnmower is actually going. Now the x-axis shows the independent variable, which is the variable that is purposely changed in an investigation. So in our case here, the independent variable is time. So this one doesn't really get altered based on what is going on. That is why it's called independent. It's independent of the situation. Our y-axis shows the dependent variable. So this is the variable that is measured as it changes in response to the independent variable. So here it is distance. And this just means that the distance that my lawnmower travels depends on how much time I've spent driving it. Awesome. So you may have heard me talking about independent and dependent variables in our ecosystems unit or in math class, but I just wanted to touch on that one more time because it is very important when you're constructing a graph. Awesome. Now we're going to talk about what you see on that graph. After you've plotted your points, which I'm sure you've done before, you get to look at it and see what kind of story it's telling you. Now we have two different graphs here. And when we look at our one on the left, the distance time graph of a hockey puck, you notice that it is a very straight line. Now this actually indicates that it's a constant velocity or a steady speed. It's always traveling at the same speed. It's never speeding up, never slowing down. And we can actually look at this graph and notice that. You notice that after 1 second, it's traveled about 5 meters. After another second, right, it starts at 5, it's traveled about another 5 meters. So you can see that it has a steady speed of 5 meters per second, give or take. Now the one on our right hand, this distance time graph of an ATV is a little different. You see that it's kind of curved down here, and then it starts going in like a straight line, and then it starts curving again the opposite way. Now this is realistically showing the motion of an ATV. Now when you have a jagged line like this, it indicates that the velocity of an object is changing. It's not staying at a steady speed, which is exactly what happens when you're in an ATV. You slowly speed up, and then when you want to stop, you gradually slow down. Right? If we got into a vehicle and instantly it started driving at 60 kilometers an hour, we'd be thrown back in our seats. We need to slowly accelerate, and that's exactly what this graph is showing. So after 1 second, you can see that the ATV has traveled approximately 5 meters. However, after those 2 seconds, right, I'm already at the 5-meter mark. It's actually traveled almost 15 meters. So I went from traveling 5 meters in 1 second to now 10 meters in 1 second. I'm speeding up, and that is why I have slight arch to this part of my graph. Then I can tell that this is a straight line portion here, so my ATV is traveling at a steady speed. And then it suddenly starts to curve the other way. And this actually indicates that my speed is slowing down. So you can see that at the 3 to 4 second mark, I traveled, give or take, from the 30-meter mark to, let's say, the 37-meter mark. So I traveled about 7 meters. However, from the 4 to 5 second interval, I only traveled from 37 to 40, so only 3 meters. I'm definitely slowing down. So, main takeaway from this is if it's a straight line, you're going at a steady and constant speed. But if it's a jagged line, that means that I am slowing down or speeding up, but I'm changing my velocity in some way. Now, one really useful thing about distance time graphs is you can calculate the speed, right? I don't have to just know that I'm going steady or speeding up or slowing down. I can actually tell how fast something is going. And we're going to talk about that right now. So you can use distance time graphs to determine the velocity of an object. To do this, you calculate the steepness of the line in the distance time graph. And this is called slope. You may have remembered this from math class. So, the steepness of a line on the distance versus time graph represents the velocity of an object being studied. So the steeper the line, the faster the object is actually moving. So if I were to look at this picture here and ask you which line is indicating the fastest speed, you just have to find the steepest line, which would be the green one right here. And because it's straight, we also know that it's a steady speed. This blue one right here is very arched and curved. So that means that it's actually getting faster. I'm starting off, say this is 1 second. I only covered a small amount of distance. In my next second, I covered slightly more until over here I'm actually covering quite a bit of distance within 1 second. So I'm slowly accelerating. Another interesting thing is the story that the red line is telling us. It's telling us that we are traveling at a steady speed and gaining distance from our starting point. And then we have this flat line. And what this is actually telling us is that our object is stationary. So the distance is not changing as time passes by. This would be like me standing in a classroom. My distance away from the door is not changing, although time is passing by. This next portion here is showing that my distance is actually decreasing from our starting point. meaning that I'm getting closer and closer to where I began. I am now walking back to my starting point. And since it's a straight line, I know that it's at a steady speed. Now, it is important that we figure out how to calculate slope, also known as just how do we calculate the velocity of a line, how fast something is going on a graph. So for this, we are going to choose 2 points on the line, identify and record the coordinates of the 2 points. I'm going to show you how to do this in an example. The next step is to find the rise. This is the distance interval between the 2 points. To calculate rise, we're going to find the difference between the 2 y-axis points that we have chosen. To find out run, we are simply going to find the time interval before the 2 points. So how much time passed between my 2 x-axis points? This is called the run. Number 4 is to find the velocity. So we're going to divide the rise by the run, and this gives us our slope or our velocity, how fast that object is moving. Now this is the formula that we are going to use. And yes, it is going to be added to our little formula sheet that I will be linking to by the end of this week. So we have m, which is just equal to slope, and y2 minus y1 divided by x2 minus x1. Now these are our x and y coordinates, and I'll tell you about that a little bit. So we already talked about this, it's velocity. This represents our rise, or the difference in the distance. And our x's down here represent the run, which is the difference in time. All right, so here's our example. Our very first step, if I would like to figure out how fast this object was moving, is to choose 2 points. I'm going to go ahead and choose this one and this one. All right, so we do know that each of these dots have a coordinate system. Kind of like if you ever played Battleship, when someone says A1, you know to look under row A and then 1 for the columns. It's kind of like a code like that. So X is representing the number on the x-axis that lines up with my dot. So for my point here, it's lining up with 2. And for my y-axis, my y1, it's going to be 2 as well. If I look at my second point, which is going to be x2, y2, I now just line up my x-axis point, which is 4, to my y-axis point, which is also 4. They're not always going to match like this. However, it's a very nice example to help us get used to this idea. Now that I have my coordinates, it's time for me to calculate the rise by finding the difference between the 2 y values. So this is y2 and this is y1. So y2, so I always write out my code, right, my equation, and y2 is equal to 4 minus 2, which is y1. 4 minus 2 is 2. That is my rise. My third step, is to now calculate the run by finding the difference between the 2 x values. So this is x2 minus x1. You always want to put x2 or y2 in front and x1 or y1 in the back. And once again, this is going to also be 4 minus 2. Once again, it might not always be this way, but it's a good way to practice. Our fourth step is to now calculate slope. So this is going to be like saying velocity is equal to rise over run. I'm going to put my number from my rise at the top and my number for run at the bottom and divide. And now I have my velocity, which is 1 meter per second. So I always want to make sure I include that unit. right? I know my distance was measured in meters, my time was measured in seconds, and that is why I left with that unit over here. Awesome. Now that we have practiced this a little bit, I'd like you to try this yourself. There are 2 practice problems that are going to ask you to do the exact same thing. You're going to be given a line and trying to calculate those numbers. You can pick any 2 points on a graph or on the graph. So I always like to try and line up with a nice number. So maybe 4 and then go across. And that one is equal to 125. So that would, X would be 4 and Y would be 125. And now you just need to find your second coordinate for that one. I hope that that helps you out a little bit. I know that this might be a little bit difficult to read, however, just try your best. All right, I also have a blown up version here so I can help you out. And you have one more problem as well where you're calculating it for a go-kart. So hopefully that makes sense, everybody. And I hope you're having a great day.